Good morning, everybody. Myself, Rajiv Kumar Chauhan. I'm a visiting and I'm a research scholar with IIT Mandi and former visiting scientist with the University of Texas, Austin. My talk topic is DC distribution system for energy efficient building. So I'm talking about the energy efficient building in terms of electrical engineering, not in the form of civil engineering. Means how can we make a energy efficient buildings in a if a building consumes the less power consumption inside the building. So I will show few energy efficient appliances through the using of energy efficient appliances we can reduce the power consumption. Second thing is DC distribution system. So DC distribution system is the new technology. We can say new in the present scenario, but it is the starting of our electrical engineering. So using DC distribution system, how the energy efficient appliances are much compatible with the DC distribution system. So I will discuss this. So this is our present layout of the power system. So the power plants, conventional power plants are too much far from the load end. So to supply this load, we have to connect the we have to use the transmission lines, and it means we are wasting the energy in the transmission as well as distribution line and the conversion stages to step up and step down in some power electronics devices. So if we will save this energy, then definitely we can reach our power demand, peak demands. So this is the literature. In India is running nearby 11% peak demand in the present scenario, and we are in the power losses in transmission and distribution systems are more than 24%. So if we will reduce this one, then definitely we can achieve this target without increasing the power generation with the existing systems. Another one is power consumption in the commercial and residential buildings is increased 20 to 40% in developed countries. So if this demand commercial and residential buildings can be reduced if we use more energy efficient appliances inside the buildings. So this is the existing layout of a buildings in India as well as in other countries. So we can see if we are going to introduce a renewable energy sources, then we have to interconnect the DC to AC converters with our existing AC distribution system inside the buildings. It means, and again, our electronics appliances like computer, TV, mobile phones, and even hybrid vehicles. What is the hybrid? Hybrid vehicles is basically a battery. Then, if you want to interconnect with the buildings, then it uses a DC supply. So again, there is a converter to charge our battery bank, because we don't have in Indian scenario, we don't have a 24-hour power supply. Then if a customer want a 24-hour power supply, then he has to use a inverter at his home itself. Then the power losses is here. So it means we can see there are a lot of converters or inverters are included with this present AC distribution systems. So energy storage devices, battery and electric vehicles, these are basically DC in nature. So if we have a DC distribution system, then we can connect these storage devices directly without introducing any converter. Then another renewable energy sources. These renewable energy sources are much compatible and it can be stored very closer to our load side. It means if we give the preference to the renewable energy sources, that definitely is not transmission and other losses will be reduced. So this is another benefit, one benefit of the renewable energy sources. And second one is these are the output of the PV is DC in nature. So definitely, if we have a DC distribution system, so no need to introduce a converter here. If you go for the appliances side, then the LED is 10 to 100% more efficient as compared to the tungsten bulb. which is used earlier, but nowadays we can see everywhere we are using either CFL or LED lights. So these are means we are saving the energy in the by using the more energy efficient appliances. The microgrid appliances utilize the BLDC motor. So earlier the problem with the DC motors was to replace the brushes and other things, but now if we are using the BLDC, then these problems have been sorted out. So we can use the DC appliances. So other appliances inside the buildings may be fan. So DC motors give the better speed control also. And
DC motor will be used. Microgrid applications will apply very normal appliances.
yeah, I am going to discuss the same. So like fan, this is DC means we can use this is basically a motor, so we can use a DC motor here, and refrigerator, air conditioner, washing machines all are DC primarily. So we can use a BLDC motor inside this. So it will increase the efficiency of the appliances, means the power consumption inside the appliances will be less. So and the electronics, all electronics like mobile, TV and computer, they use the DC supply. So no need of the adapters, and the local adapters according to survey they have a nearby 70 to 75% efficiency. It means we are wasting nearby 25 to 30% power inside the converging from one state to second state. So these are the DC parameters through which we can use the existing AC distribution system also. If we have a suppose according to the India voltage level, if we have a 230 voltage, then same distribution line can be used for 325 volt DC supply. So that if we have a high, we for the same lines, the current rating of the lines will be reduction in the currents will be 29%, and the power loss in the line will be 50%. And if we compare with this voltage level with the American scenario, then the current rating will be again reduced up to 66, and power loss in the line will be approximately 88%. So total daily load, actually as I discussed, we have to use a battery bank. So we have to, if we want to optimize which size of battery bank is required with the same load. So this is another challenge. Here these are the basic formula to calculate the power, how much long our battery bank will supply for a particular load. So here this is the power rating of a DC load, and then the standard voltage for a particular DC distribution system, and these are the number of operating hours in a day. If we have a variable load, sometimes on and off, then we can go for this. And if we have a AC distribution systems, then the inverter efficiency and the voltage of the system is affecting the supply hours of the battery bank. So these are the calculation I pointed out. If we have a 2.4 kilowatt load and we connect it with a different DC as well as the AC voltage levels, then we can see for if we have a 24 volt DC distribution system, then we need a 2400 ampere hour battery bank. And if we have a 48, then it will be 1200. Here we can see if we have 120 volts and the power rating is same, but the efficiency of the inverter is 92%, and we need it little bit higher even as compared to the 224 volt DC distribution system. And if we go for 110 volt, so it means from here we can see for the two different voltages, one is 120, second one is 220. It is not affecting our AH and total daily load. It means the voltage level of AC distribution system is not affecting the power size of the battery bank, but the inverter efficiency, we can see that we are going a little bit lower voltage level, but if the efficiency of the inverter is higher, then we require a less size of battery bank. It means we are saving the energy in the conversion stages. So this is the proposed DC distribution system. I have used the unipolar distribution system. Unipolar system means we have a 3-wire system, but I have shown here only 2, positive and negative, and third one is we can see by the white lines. I did not highlight that third wires here. So what is the benefit of this? We can connect to the two different voltage rating appliances without using the converters. Like if we have a 24 voltage distribution systems, then we can connect the 24 voltage appliances as well as 12 volt appliances without using the converters. If you want to connect a 24 volt, then use the positive and the negative. And if you want to connect the 12 volt appliances, then we can go for a positive or neutral or negative and neutral. So this is the another benefit. And here we can see that there is no need to connect a solar panel with the inverter or a converter. Means we are replacing this converter, and on the another load end, the computer and TV, they are using the DC supplies. It means we no need to use a internal or external AC to DC converters here. Only I use a one DC to DC boost converter here for a high rating of loads, because to minimize the current inside the lines.
So it is 24 volt VDC or 240? What is this?
This is 24 volt. This is 24 volt. I am coming why I am using 24 volt. Actually, this is the list of appliances which is easily available in our Indian market. So we can see here we have only three different voltage rating. One is 12 volt. Second one is 96 for electric geyser of heavy load, and third one is 24 volt. So these are the list of appliances we are using here. So power rating specification of our system is this one, 24 volt DC distributor, and panel voltage is this, and the battery bank is I use a two battery for a 150, and then second one is two battery inside the hybrid vehicles. So total is 4 here. So this is the power consumption in the AC distribution system and DC distribution system. So here we can see, and third one is ideal load. Ideal loads basically what? This is the total power consumption only inside the appliances. More means highly efficient appliances. So here we can see the green line represent the power consumption in the case of DC distribution system, which is very close to the ideal load, and in the impulse shows that the power consumption in the AC distribution system, which is always remain high and even sometimes very high with the DC power consumption in the DC case. So this is the for to supply the buildings, we have also monitored the data for a power consumption from the public utility as well as the power consumption from the solar panels. So when the solar panels are available and the public utility, we can see the power consumption in the case of DC distribution system is less as compared to the AC distribution system. So here the battery bank is also, we required a less size, because in AC case we required a more power. To supply the more power here, this is the negative part. It means we are charging the battery bank, and positive represent the power supplied by the battery bank. So we can see we required a large power for in the case of AC distribution system. Then definitely we have to use a bigger battery bank. These are the power consumptions inside the AC distribution system and DC distribution system. In the day hours, we can see in these hours the solar panel is there, means we are supplying our home using we are consuming the power from the solar panel. It means in this case we can see the power consumption converter losses is approximately very closer to the zero, and here we can see why this power in this hour is also solar panel is there, but why these converter losses are existing, because I use one single DC to DC converters. So these are the power consumption in that converter. So this is the total power consumption in the converter losses for AC and DC distribution system. Here we can see this is the total ideal power consumption in the case of ideal, and this is the power consumption in DC distribution system, which is very close to the ideal load. And the power consumption in AC distribution system, we can say this is little bit, means not little bit, this is too much high for a single, if we are going for a single. Okay. So this is the conclusion part. we have a number of conversion stages for less number of conversion stages for a DC distribution system, and ideal load is 14.75. The power consumption in DC distribution system is less as compared to the AC distribution system, and the very good thing is that we have a very less converter losses in a DC distribution system as compared to AC. This is approximately 6 times.
Are these two separate circuits? The DC wires are separate and AC wires are separate?
Yeah, means I compare with different. If for a same building, I have a different separate system.
So you have different circuit for AC and different circuit.
Yes.
And have you commented on the losses in the lines themselves?
No, not
Why
by
not?
converted here.
Why not?
Because we can. This is the voltage ratings, which is very close. Means the extended version is coming. Means going for general basically.
Oh.
So I did not mention it here.
What do you mean by that ideal load?
Ideal loading means power consumption. We have a highly efficient appliances in the building. The power consumption inside the appliances only, not in converter and other things.
That means the rating of the load.
Yeah, you can say. Power consumption at the rated rate.
They have you said it's a unipolar system.
Yeah.
You have plus and minus. So what do you exactly mean by unipolar?
I discussed. I have shown only two wires here, and third one is because of the consistent. I speak. There are 3 wire system. One is positive, second one is negative, and third one is neutral, which is not highlighted here. Third one is unipolar means we have 3 wire system in which we can, if we connect the load or source with a positive and negative, it means that it will be 24 volt. If we are connecting the load or source with the positive and neutral or negative and neutral, it means it will remain 12 volt.
You need to say with respect to ground and positive you will connect something.
Yeah.
Or with respect to ground and negative you will connect something.
Oh,
That's what
yeah,
I mean.
and the remaining one means if the voltage rating is high like 24 volt, then we connect it with positive and negative.
Same thing, but you also say.
Yeah.
Any other question? Oh, thank you very much.
Thank you very much.